Yeah. Okay, sorry about that. I didn't have anyone around to turn on the gen for me, so I had to go turn it on myself. We were talking about this question four. I was about to, discuss it with you guys, how I was thinking about it before we had that power interruption. Um, Trust me, Nigerian NEPA is nothing to write home about. Trust me, man. We struggle with power. We have to supply ourselves power like we don't have a government. It's something else in this country. Okay. Having that said and done, I already explained to you that this function prints that this function here prints an array out to the screen, and then this one is that we are supposed to build is to reverse, you know, the order from the behind to the front, or from the last one to the first one. We should reverse the order. This is the expected output. The first time it's being printed, this how it is. After running our function, reverse array function, it should now be like this. And then, like I said, I was thinking about this in a way that we can, swap this. We could do a kind of loop that goes through this thing, and then it keeps saving the last one and the first one, and it switches their order. It saves this one in here and saves this one in here. It goes to the next one, it collects this one and this one, and then it switches them till it gets to the middle, and it switches the ones at the middle as well. So that's how I see it. That's how I think about it. You can have a different approach to this stuff. You can see it in a different light, but that's how I'm seeing this stuff right now. And the reason why I'm doing this is because I want to teach you people the concepts behind, using pointers. You know, um, yeah. So having that said and done, let's continue from where we stopped. Yeah. So I created three variables here that I would be using to do this stuff. And to start with, I wanted to use one of my variables to have the highest number, to know the highest number of this stuff. Remember, when accessing an array, the first let's go here. When accessing an array, the first character, the first position of the arrow is position 0. This position 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So they're like position 12 of this. But then if you count it like normal, the total number of items in this array, it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Do you understand? So what we should do if we want to know the total number that could be indexed here is we are going to say the total number minus 1, because the first one is obviously going to be 0. Okay, so if we come here, we can say, this is not where I was. Yeah, if we come here, we can say let's use y to be equal to n, which is the total number of items in that array, minus 1. Let's make this look neat. Yeah, minus 1. Yeah, so we now know the total number of items that could be accessed or indexed, that could be indexed. That's the right word for it in this array. So next thing I want to do is I want to do a for loop, checking through all of them to the total number, you know, and I want to check side by side, you know. Let me start the for loop. I've taught you guys how to write the for loop. This is my for loop. It's very easy to write. Okay, and then we'll come here. Let's initialize x. Let's use this other variable here, s, so you guys see how I think about this stuff. We can say x here is equal to 0. Remember, the first position of x is 0. Don't forget. Now we want to check. Uh, Remember, we are switching this thing, the right to the left to the right, right? So we want to check, since we are switching the right to the left to the right, yeah, we don't want to go past half of it, because by the time we do switch right to left, left to right for position one, we've already solved the problem at the other end, you know, at the by the time you solve at the first position, position zero, it means you've solved at the nth term, the last position. In mathematics, in arithmetic mean, they call it the nth term, the final position of it. You know, you've solved the n because we are swapping. By the time you solve position two, it means you've solved the n term minus one. You know, that's what it feels like. So we don't want this to get to more than, let's say, when x, for if x is less than n divided by 2, yeah, check for when x is less than n divided by 2, and I see an error already. We used comma here instead of a semicolon. Remember, this is like a new line of code in this stuff, in this for loop. Then we want to say x plus plus, because yeah, this solves the problem. We are swapping. Our idea is to swap, right? So since our idea is to swap, we want to swap till we get to half of the the array. We don't want to swap till we get to the end, because what then are you swapping with? Remember, at the middle point, at the midpoint, you're swapping with the midpoint of the other. Let me just come here. Let's see this. Yeah. So take a look at this stuff. If we are swapping, since swapping is our idea right now, when we solve for this first position, we're already swapping it with this one. When we solve for this one, we're already swapping it with this one. So the first time this array runs, it solves the problem at the front and at the back. The second time it solves at the front and at the back. So we don't want the array to pass the midpoint, because when it counts and passes the midpoint, what then is it swapping with? Nothing at this other side. You understand? So we want it to stop at the midpoint here. So it's free flowing. Like everything will be solved by the time we get to the midpoint, because each time it solves both at the front and at the back. So yeah, that's basically what it is. What this feels like. This is why we are saying x should increment until x is like the half of the total number of x. Okay, so yeah, let's go forward and you know let's go forward. Now, the next thing we want to say here is, remember, this is a block of code, so we have to go inside. We want to create a temporary variable and say that this is the current value of x. Let's make it temporal. Store it in our temp variable. The current value of the array a at position x, which is 1, which is 0 now. The first index is position 0 at this point. So that will be 0 for now. We want to take that, save it in temp, and then we want to change a at position x, we want to change it to a at position y. Remember, a at position y is the total number minus 1, which indexes the last one. So we are changing the current value of ax, which is a at position 0, to we are changing it to a at position uh, y, which is the last term, the nth term, the final term, n minus 1. Remember, n was one digit above, since we are starting from 0 to index. And now n minus 1 is the last character in this array. The last position index in the array is n minus 1. In essence, we save the original first value, which is x at 0 here. We are saving it in this temporary array, temporary variable. And then we are coming here to swap it. We are now saying that the current value of ax should now be ay, which is the last value of the array, a index y, A index x is 0, A index y is the n term minus 1, the n term, the last variable at the end. So we've successfully swapped this. Now, what we want to do here is we want to decrement the value of y. Let's cover this. Ay minus minus, right? This stores the, and we want to store this, we want to say this is equal to 10 as well. Yeah. So ay. Now we've stored ax. Remember, temp was the original value of a at the first position, which is ax. X is 0 at this point. So the array, which is a at position 0, was initially 0. So we now said ax, we stored it in temp. Then we changed the value of the first position of a to the last index of a, and now we want to change the last index of a to temp, which was originally the first index of a. That now, so we just swapped, we changed the first one to the last one. That's what we've done here, right? And this solves our problem. It's going to increment. The next time these for loops run, it's going to increment. And what it means is it's going to increase x at position 0 to x at position 1. And it's going to increase y minus minus to, y minus minus again. It will remove another one from the last position again. And it will keep doing that till x becomes half of the array, which means it has solved all, since it's solving from the front and the back at the same time. So this solves our problem. Okay, this solves our problem. This is all that we need to write to solve that problem. Let's ls to see if we had added the main.c file. Okay, so yeah, we added the main.c file here, and what we can do here is we can chmod this stuff. See, automatically converts this thing. I just keep doing this stuff as good practice, in case your system does not do it. Yeah, so we have to run gcc on this, gcc 4-main.c and 4-rev.c, and we want to put this in an output file called 4-rev. Yeah, no .c anymore. Let's see, are we going to have an error? So we are not having an error. That's to say that we are correct in this. So let's check 4-rev.array. As you can see, this is very correct. So our function does the reverse engineering for this stuff as well. Yeah, so this is how I think. This is me building this stuff, from my mind. Don't think I did this sitting down here. I did not just do this sitting down here. I had a pen and a paper with me, and I thought about this stuff. I thought about the variables I wanted to add in this stuff. The reason I can do this from the top of my head, looking at this thing, is because I've been doing this for a while. I've been writing code for a long time. Okay. Echo official. Good morning. I've been writing code for a very long time. That's why I can sit and do this stuff in front of you. But then for you that is a beginner, you are supposed to write pseudocode. I taught you guys about pseudocode. You're supposed to use like a pen and paper, and in our normal English language, not C programming language. You're supposed to like write this thing, write out your algorithm, how you feel like when you see this problem, when you read the question, how you feel. You're supposed to write it out. What you think you should do to solve the problem. You know, in every step of it, you're supposed to write it out, and then you solve the problem. Okay. Um what do I do? What do I do for you guys? Do I take another one before I leave? Or do I let you to go solve it all? Do I take one more? Or do I let you solve it? Okay, let me just take one more. Yeah, I think I should take this one just because it has to do with like ASCII table stuff, and we've not thought about ASCII table in like a while. So let me take this one. Okay. So it says write a function that changes all lowercase characters to uppercase, and this is what it should be taking, string to upper. Okay, so let's copy this prototype. We'll copy the prototype. Is this supposed to be the prototype? Oh yeah, it's supposed to be the prototype. See it here. Okay. So let's copy that prototype and go dump it in our main.h file, right? So vi main.h. Okay, we've copied that prototype. We are dumping it here. Let me copy the main.c file and dump it here as well. Yeah, to use cards. Let's go copy this. So copy. So we are copying the main.c file. It's supposed to return lookup in capital letters, and here it was written in anyhow less in initial capital. Okay, so we should come here, copying this stuff, and where's this stuff? All right, so cat dash. This is the last one I'm going to do for you guys. Vibe that main.c and done. um what's the name of the file we have to create? We have to create five string to upper, five string to upper, string underscore to upper together, five dash string underscore to upper. Okay, vi five dash string underscore to upper dot c. Okay, so that's it. This is what we are creating. First things first is we created the main dot h file, so we have to include the main dot h file to this code. And the next thing is our character was a pointer, right? String underscore to upper. And it was taking in a character that's a pointer to x, right? So it well. Yeah, so that's what that is. And how do I feel about this when I see this? How do I feel about this? Um I feel like we should do a for loop. Is a very simple one that looks through the ASCII table value of this stuff and prints the of all the characters and prints the corresponding ASCII table value